That allows us to see this kind of previously hidden aspect of a galaxy in this amazing detail.
Our universe is filled with millions and billions of dwarf and gigantic stars. These stars can be dim or bright, regular or strange. They are all connected by invisible gravitational lines, creating galaxies and star clusters. Our unimaginably huge Sun is one of approximately 200 billion stars that make up the Milky Way galaxy, which itself is one of many. Galaxies are bustling with fascinating activities as they form, grow, and merge. Inside, they have a pretty complicated and well-organized structure, determined by the basic laws of nature, and these galaxies have their neighbors too. In today's video, we are going to dive deep and see what the closest galaxies to us look like. Without wasting any time, let's explore. So, how many galaxies are there in the universe? I'm pretty sure this question has crossed the minds of many of us, more than once, and the answer to this question is not accurately known as of today. But there are approximately 100 billion of them. These galaxies may be of all sorts of different shapes and come in different varieties. For example, elliptical galaxies, spiral galaxies, lenticular and irregular galaxies. These varieties also include subcategories. For example, the Milky Way galaxy is a barred spiral galaxy with a central bar-shaped structure composed of stars. Anyways, similar to our Milky Way, these galaxies contain a humongous amount of stars, and thus reach masses of unbelievable values. If we take an example of the dwarf galaxy, Segway 2, it possesses a mass 550,000 times that of the Sun. On the other hand, the supergiant IC 1101 elliptical galaxy is 1,700 times heavier than the Milky Way. As I mentioned before, our galaxy has about 50 immediate neighbouring galaxies, and together with them, it comprises what is known as the local group. Some of the galaxies in this local group are pretty large when compared to others. These galaxies include the Milky Way, the Andromeda, and the Triangulum galaxy. This local group measures 10 million light-years in diameter, and its mass is about 3 trillion times that of the Sun. Along with a couple of other groups of galaxies that are not too big, the local group includes something called the local sheet. This is like a flat cloud, and it's about 23 million light-years wide. It's also around 5 million light-years thick. The local sheet is the reason behind the formation of a part of the Virgo supercluster, a large element of the large-scale structure of the universe. The local group is further divided into 4 groups. The first one is the subgroup comprising our Milky Way, alongside other dwarf galaxies and star clusters. The Milky Way galaxy is the second largest galaxy in the cluster. It contains approximately 200 billion to 400 billion stars and around 25 to 100 billion brown dwarfs. The Milky Way galaxy is a barred spiral galaxy with a spiral structure. It appears to be a disk and measures about 200,000 light-years in diameter and is about 100,000 light-years thick. It contains a bulge in the middle of its disk with a diameter of around 27,000 light-years. The interesting part is that inside the bulge there's believed to be a humongous black hole, weighing about 4.3 million times more than the Sun. In addition to this, there's a small black hole circling it, with a mass ranging anywhere from 1 to 10,000 times that of the Sun. It is said that it is dark matter which accounts for most of the mass of the Milky Way, which is why it is impossible to measure it at this point. But what we can estimate is the mass of our galaxy, which is around 1.5 trillion times the mass of the Sun. When we move a little further from the Milky Way, we can observe its 31 satellites, which are mostly irregular-shaped dwarf galaxies. These galaxies become twisted and bent in various directions due to the strong gravitational pull from their larger neighbour. The closest galaxy to our galaxy is the CMA dwarf galaxy, which is around 25,000 light-years away from the Earth and about 42,000 light-years away from the centre of the Milky Way. This galaxy resembles a stretched oval and holds around 1 billion stars, mostly red giants. Due to the gravitational influence of the massive Milky Way, the Canis Major dwarf galaxy is on the verge of breaking apart. Tidal forces have had a disrupting effect, causing stars to be poured out from the galaxy and form what is known as the Monoceros Ring, a complex ring-shaped structure that encircles the Milky Way. Unfortunately, observing the CMA dwarf is hindered by the gas and dust clouds that float between the galaxy and Earth. The fourth largest galaxy in the local group and the largest satellite of the Milky Way is the Large Magellanic Cloud, which is located as far as 163,000 light-years away. This satellite galaxy holds an estimated 30 billion stars, has a diameter 7 times less and a mass 30 times less than that of the Milky Way. The reason for this significant difference is that the Large Magellanic Cloud doesn't have a supermassive black hole at its centre. In addition to this, the Milky Way's galactic halo contains substantial amounts of dark matter. The Large Magellanic Cloud is an SBM type, meaning that it falls in the category between the dwarf spiral and irregular galaxies. Even though the strong gravitational influence of its massive neighbours has erased almost all traces of its former spiral structure, the bar in the centre remains distinguishable. The Large Magellanic Cloud also contains one of the most massive and luminous stars ever detected, the star R136A1. This blue supergiant lies 165,000 light-years away and possesses a mass 315 times that of the Sun. Not only is this star one of the heaviest, but also one of the hottest. Its surface temperature is around 46,000 Kelvin. If you don't know how hot that is, let me break it down for you. This star, ladies and gentlemen, is 9 times hotter than our Sun. The luminosity of R136A1 is 8.7 million times that of the Sun. The LMC also holds one of the heaviest stars in the investigated parts of the universe, the red giant Hu G64. The diameter of this giant is 1,500 that of the Sun, just 25% less than the diameter of the largest supergiant ever detected, Stephenson 218. According to the current concepts of stellar evolution, Hu G64 is presently in the last phase of its life and is expected to undergo a supernova explosion within the next few thousand years. When we move 2.5 million light-years further away, we reach the Andromeda Galaxy, and along with its satellites, this galaxy forms a part of the local group. The Andromeda Nebula has a diameter of 220,000 light-years, which is slightly more than that of the Milky Way. It has a star count of 3 to 5 times more than that of our galaxy. However, on the interesting part, both Andromeda and the Milky Way possess the same mass, which is about 1.5 trillion solar masses. But why is that, you may ask? Well, the reason for this is that the stars in the Andromeda Nebula are generally older and lighter than those in the Milky Way. Andromeda is one of our closest galaxies and is one of the few galaxies visible to the naked eye. It is a spiral galaxy with well-defined arms and a distinctive core. When we observe Andromeda through a telescope, 2 clearly visible star clusters in the galaxy's centre are separated by a distance of about 5 light-years. Now, there are many theories regarding Andromeda's history. One theory suggests that Andromeda swallowed another galaxy, capturing its core, and another one says that there is a single core with a part of it concealed by a dust cloud. The mass of the central part of the Andromeda Galaxy is estimated to be around 140 million solar masses. Andromeda contains about 30 satellites, but only 2 of them are worthy of your attention, M32 and M110. Many theories suggest that M32 orbited the Andromeda Nebula several billion years ago, leaving a notable hole in its structure. Following this event, a huge part of M32 became Andromeda's galactic halo. Many scientists and astronomers say that the Milky Way and the Andromeda will collide with one another in about 5 billion years. It will truly be an incredible event. Now we move on to the third member of the local group, which is the Triangulum Galaxy, which is about half the size of the Milky Way and has no confirmed satellites. The Triangulum Galaxy supposedly doesn't have a supermassive black hole at its centre. It has a diameter of 50,000 light-years and is located around 2.7 to 3 million light-years away from the Milky Way. The largest known region within the Triangulum Galaxy, where stars are actively being born, is the NGC 604 Nebula. The diameter of this nursery is 1,300 light-years and holds around 200 supergiants with a mass of 100,000 solar masses. In the broader local group, there are many objects not falling in the mentioned subgroups. These objects include dwarf galaxies or star clusters, not gravitationally connected to the three biggest galaxies in the local group. An example of this is the galaxy IC10, located 2.2 million light-years away, and is the only galaxy in the local group where stars are actively being born. Even the largest of the galaxies appear to be small in the vast structure of the universe, and it takes millions of years for the light to even reach from one galaxy to another. By taking small steps, we will surely unveil more and more spectacular phenomena of space and its secrets. That's the end of the video. Tell us your thoughts in the comments section. We'll see you next time. Until then, take care.